Question 8. We have a country estate in Scotland with 10,000 grouse that grow by 10% and 2,000 are shot. So let's call P0 10,000, this P0 which is 10,000. And if we imagine that's the population now in a year's time, the population in a year's time is equal to 10,000 by the growth rate, take away the 2,000. So Pn plus 1 is equal to P0 by 1.1 minus 2,000. So this is when n is equal to 0, so P1 is when n is equal to 0, so we'd get this Pn by 1.1 minus 2,000. So let's look at P2 is when n is equal to 1, it's going to be P1 by 1.1 minus 2,000. P1 of which we already have, so I'll bring the 1.1 in front and multiply it by P1, 1.1 1.1 P0, leave them as zeros instead of n's, minus 2,000, and then a minus the other 2,000, this one. So we have 1.1 squared by P0 minus 1.1 by 2,000 minus 2,000. You may see now that this is becoming a separate pattern with our geometric progression. If we reduce it around it, we'll have 2,000 times 1 minus, we'll have minus 2,000 times 1 minus, actually 1 plus 1.1 plus 1.1 squared, and so on. So A is equal to 1 and R is equal to 1.1. So we have A times 1 minus 1.1 to the power of n over 1 minus 1.1, and we'll have this minus 2,000 in front. So we're going to get minus 2,000 divided by this 0.1, which is the same as multiplying by 10, and they're both minus, so we're going to get plus 20,000 times 1 minus 1.1 to the power of n, which is 20,000 minus 20,000 times 1.1 to the power of n. And we bring down 1.1 to the power of n by P0, which was 10,000, I'll put it in front, and then plus 20,000 and minus this guy, we're going to have 20,000 minus 10,000 times 1.1 to the power of n. So that's solving the difference equations, just putting 4 in and 5 in. I'll just do that in the calculator. 5359 is what 4 is. 5 are going to go extinct, they're going down. 5 is giving me 3895. In how many years will it reach 0? So this guy would have to be equal to 0. So bring the 10,000 across and divide by 10,000, and we'll just get 2 is equal to 1.1 to the power of n. So n by the log of 1.1 is equal to the log of 2. So n is equal to the log of 2 divided by the log of 1.1, 7.27 years. Did I ask for to the nearest year? No. And if you're advised the owner of the estate, what's the max number she should allow to be shot? I suppose this is so they don't go extinct. So this kind of brings us back up to this point here. So the 2,000 comes from, or the 20,000 comes from this, the amount being called divided by this 0.1. So if we call the amount being called, let's call it K divided by 0.1, that's going to give us 10K. So we can rewrite the expression with 10K instead of the 2,000 in there. So it's going to be 10K times 1 minus 1.1 to the power of n, and we have that's these two, and then this 10,000 1.1 to the power of n. It's going to be plus and a minus. So if we just rewrite this again, 10,000 by 1.1 to the power of n plus 10k, and then minus 10k times 1.1 to the power of n. We have a common factor here of 1.1 to the power of n, so we factor that out of 10,000 plus 10k minus 10k, and then we'll have plus 10k, and this has to be greater than 0. So we look inside here, k obviously if it was 1, so if this becomes negative, we'll end up with a negative population, which we can't have, so this needs to be greater than 0 to maintain a population. Greater than 0, so 10k would have to be greater than or equal to, be less than or equal to, if we reverse it around, so k would have to be less than or equal to 1,000 to maintain a positive herd of grouse.